Okay, so this homework not due till 11:59. Dean and Gavin trying to catch you up because the microphone stopped working, but supposedly it's working now. Not due until 11:59, but I'm going over questions. Have you? Oh, hi, webcam that decides to stop working. Do you guys have anything that you want me to see in homework or look at in homework or help you get through where you've gotten stuck in homework? Nothing? Absolutely nothing? Yeah, Jacob.
27.
27. Anything else besides 27? Yeah, Victor.
60.
60. Both of these on section 10.4?
Yeah.
Okay. 27 and 60. Anything else going once, going twice for right now? Which one? 21. All right, start with 21, then we'll go to 20. Uh-oh, there we go. Start with 21, then Jacob, sorry, 26 or 27? 27. So number 21, the directions as I look at it are find the radius of convergence. Wait a minute. Just the radius? Just the radius. If it's just the radius, guys, do I need to be testing endpoints? I guess we'll see when we do it now, but I think the answer is no. So when I'm looking at 21, I'm kind of stalling because my snipping tool isn't coming up because, once again, we love technology. The radius of convergence comes from half the distance of the interval of convergence, whether or not, regardless of the inclusion of the endpoints. So therefore, I'm going to go ahead and think ratio test. I'm going to think the n plus first over the nth, all things that I'm assuming you did last night. I'm just still waiting for my snipping tool to come up so I have room to work. Yep, let's freak out because that's fun. There we go. Okay, so for number 21. You guys can see the final answer is 1, but let's see why it is 1. When you guys go to plug in, absolute value means you don't have to worry about an alternator, but there wasn't one anyway. The limit as n goes to infinity. That absolute value is still important for the x, so we'll keep it in there. We have x plus pi to the n plus 1, all the square root of n plus 1 times the square root of n, all for x plus pi to the n needs to be less than 1. I like to separate out my n, because that makes life a little bit easier. Keeping the absolute value over whatever is left of the x plus pi, which is just literally x plus pi. There we go. Using those absolute values around the x, which can be positive or negative. Using that to be less than 1. Oops, sorry, not x approaching infinity, n approaching infinity. But what's the limit if I have a square root of n over a square root of n? My limit is just approaching 1, so therefore I end up with x plus pi is, well, hold on, absolute value. Can't I just go ahead and put it in between 1 and negative 1? So I'm putting it in between 1 and negative 1. I can go ahead and solve for my x plus pi in between 1 and in between negative 1. I can go ahead and subtract on this side. I can subtract on this side. But then I need to figure out the distance between and then divide by 2. So I'm going to take half of what's on the right minus what's on the left. I'm going to have 1 plus 1, which is 2. I'm going to have negative pi plus pi, which is 0, and 2 over 1. In these problems, once again, we just had to figure out the distance of the interval of convergence. Is that good, Patricia? Okay. And then Jacob, number 27. It's in a different section, asking for the interval of convergence, and then the sum of the series as a function, which is where it gets kind of interesting. Skipping down here to number 27. So starting off the exact same way, the n plus first over the nth. Remember, if you're bored at all today, be playing with multiple choice, or your homework, or both. Limit as n goes to infinity. A little bit messy unless you remember the property of exponents. Any fraction raised to a power is the same thing as the numerator being raised to that power and the denominator being raised to that power. in terms of n and my stuff not in terms of n. So I'm going to have my x squared minus 1 be in absolute values. Anything 3 to the power of any n will still be positive. He can come out and end up with a 1/3. This one's a little weird because my 3 over n's reduced. I just have a 1/3. Well, guys, don't I already kind of have my expression because the limit of any constant is just itself? So I actually end up with x squared minus 1 times 1/3 being less than 1 and greater than negative 1. I can multiply both sides by 3. Get rid of my 1/3. There was no n component, so the limit of any constant is itself as far as the 1/3 goes. I can add 1 to both sides. Okay, now let's ponder a bit. For x squared to be less than 4 greater than negative 2. Hold on, x squared is only going to be between 0 and 4, but hold on. If I square root, what squared makes anything between 0 and 4? Isn't that anything between negative 2 and 2? Negative 2 would square to be 4. 2 would square to be 4. And the squares of any values in between will be in between that 0 to 4. So since that one's not positive, I can go, or not possible, I can go ahead and go to 0 instead. I can do or equal to because 0 is within that negative 2 to 4 boundary. But it needs the interval of convergence. So sadly, I need to know for sure whether or not to include the 0 and whether or not to include, the negative 2 and whether or not to include the 2. So I'm going to say at x equals negative 2. Remember, ratio test is inconclusive at its ones, or when the limit is 1, and the limit will be 1 at negative 2 and 2. I go back to the beginning. Negative 2 squared is 4. 4 minus 1 is 3. 3 over 3 is 1 to the n. Plugging in positive 2, 4 minus 1 is the exact same thing. I have 1 to the n. Hey guys, why does 1 to the n diverge? What test could I use? Yeah, you do geoseries, r is equal to 1. That works. What's the other one, which is not less than 1? Yeah, the n term. Test, what's the limit of a sub n? Not 0. So we could say by the nth term test or the divergence test. And there are other ways, of course, but those are probably the easiest ones. If both of those diverge, am I going to be including either one? Nope. So therefore, Jacob, we have our interval of convergence. Check, check, check. We could do our radius of convergence. If they were to ask for it, the distance is 4, cut in half is 2. Going 2 from the center, which is x minus 0, either direction. But they were asking that one other step, and that one other step was write it as a function. Ooh. Write it as a function. Okay. We're supposed to somehow figure out who this guy is as an actual function of x. Now, you do have endeavor number 27 that says, I'll give you some special Maclaurens. And these special Maclaurens could be rewritten as an e, or as in sine, or as a cosine, or as a 1 over 1 minus x, or a 1 over 1 plus x, or as an ln. You could go ahead and you could start looking at those, but I think it'd be a lot easier if you start writing it out. Like plugging in 0. If I plug in 0, anything to the 0 power is 1. If I plug in 1, I get x squared minus 1 all over 3. If I plug in 2, I would have x squared minus 1 squared all over 9. If I plug in 3, x squared minus 1 cubed over 27. What kind of series is this? Geo, you have something to the n. You have a common ratio. What's happening every time? I'm multiplying by another x squared minus 1 over another times 3. And that's what's going to be each and every one of those jumps. The cool thing about geo is if it is a true geo series, aka a power series, that follows the geo series pattern, I can just say, hey, I know my function. My function's easy. It's just a sub 1 over 1 minus r, where my a sub 1 and this one is 1, and my r is, well, this whole thing that gets multiplied over and over and over and over again. A sub 1 over 1 minus r. And then all I have to do is something sneaky, like, I don't know, multiplying top and bottom by 3 to go ahead and get rid of that guy. And then I could do 3 minus x squared minus a negative 1, which is really 4. And I have my function. So it's really nice to, and let me see real quick if it's in here, Jacob. Here we go. Recognize the series as a sum of a geo series. If geo, then we can say that the function is going to equal, can you find the first term and can you find the ratio? Remember, if it is a geo series, we can find the sum. We can find the function that encapsulates or that is the series by just plugging into a1 over 1 minus r. And that's kind of what I just did. So that's one of the ways of either making a series or using a series. Sorry, making a series into a function. Or making a function into a series. But yeah, great question. That was a tricky one for sure, as far as especially trying to figure out what it is as a function. But it was a geo series. I can always use this little baby formula for the sum, but also to make the function. So we have the function, we have the interval of convergence, and we know that neither of the endpoints work, so we stop there. And I think with that, we've finished it. Yeah. And once again, it's only within that interval of convergence, meaning 3 over 4 minus x squared is only equal to the power series, the infinite power series between negative 2 and 2. Sorry, I totally got lost as into the last or the other question we were going to look at. It was 21, 27, and 60?
Yeah,
60. Thanks, Victor. I forgot it was your question. Number 60 is a multiple choice. Ha-ha! And you guys have lots of multiple choice in front of you. Uh-oh. Yeah, don't get lost. Number 60 says, which of the following gives the sum? Woo-hoo-hoo. Remember, we can only find the sum of geo, of telescoping, and, ooh, now with Taylor and Maclaurin series. But this one, actually, this one doesn't even have an x in it. So this isn't one of those crazy like function ones. This is just a good old-fashioned series. Because remember, our book is teaching all the convergence divergence right now. So all the things that are reviewed to us to some extent are new to anyone using our book in its normal order. Telescoping. We could start plugging in right away. Boom, 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 boom. The problem is if we plug in right away, we're not going to see the telescoping because the telescoping needs the partial fractions. The telescoping needs to see something being added and something being subtracted. So my advice is to go ahead and rewrite this in terms of its partial fractions. Now here's where it's a little bit messy. Remember how I said you could always use thumb trick for partial fractions? Why is this not going to be quite as easy as using thumb trick? Yeah, the solution would be a fraction in that we'd be plugging in 1/3 for one of them and negative 2/3 as another one. But to be honest, just besides the fact that you're going to have fractions that you plug in, it shouldn't get much messier than that. I'm thinking about how you could have pulled out a 3 and n minus 1/3. You could have pulled out a 3 and gotten n plus 2/3, but I don't know if you need to pull those out in order to be able to plug in. I don't think you do, because when you go ahead and find the 0 of this guy, 1/3, 1/3 times 3 is 1, 1 plus 2 is 3, 3 over 3 is 1. So I think I'm just getting 1 over 3 minus 1. Bless you! And then I have negative 2/3, which will be negative 2 minus 1 is negative 3, 3 over negative 3 is negative 1. The way we could double check that that was totally legal is just get the common denominator and make sure we're good. So I would multiply this guy by that guy. common denominators, I would multiply this guy by the original dude. And then I would get my 3n plus 2 all times 3n minus 1. As long as the 3n minus 3n cancels and the 2 minus the negative 1 is 3. Ha-ha! I got my partial fraction. And why is that good? I need to see the telescoping. So plugging in 1, I would end up with 1 over 2 minus, and I'm plugging in 1, I get 1/5. This is going to be a little messy. Plugging in 2, I end up with 1/5, or maybe not so messy, minus 1/8 plus plugging in 3, 1/8, oh, not that bad after all, and then minus 1/11. I think I see the pattern. And then I get plus minus. Remember what telescoping does. It says, hey, get rid of anything that's going to cancel out. The 1/11 is going to is going to be canceled with something in the future. And every time I believe I was canceling out the first and then moving forward to cancel out the second, so I technically have this. My end partial sum of this guy is 1/2, this guy who was stuck, and whatever is down there. Until I go to the next term, that piece will still be there. But as I go to infinity, this piece is going to 0. I'm trying to get my infinite sum. That's going to 0. My answer is 1/2, and 1/2 will be the partial fractions. Partial fractions. Is there anything else you guys want to see on 10.4 or 10.5? or 10.5. As you guys are looking, if you notice, there is a big old chart that our book decides to do as far as convergence. I showed you guys one similar in the Parting C review that I gave you for the Chapter 9 OT test. It's pretty similar, but that might be useful. And then, it's always good to pay attention when it says a word of caution. They're trying to save us from something. This is just a quick reminder that all of these convergence and divergence tests are just telling us that they converge, not what they're converging to. There's basically saying be careful of assumptions. That's why we're doing interval of convergence. That's why we're talking about radius of convergence, because yes, there is a convergence of an infinite series. An nth polynomial will have error, will be off. And remember, it's usually only on a certain interval that the series will converge after all. Okay, sorry, anything else? There is an interesting, where was it? Just in case you want to be interested at any point or intrigued at any point. Oh, it was a good one. I think it was back in section 10.3. Yes. If you want to go play with Euler's formula, that's a fun one. That's the one that a lot of mathematicians say is the most beautiful. Ah, look. The most beautiful equation. And this is, Kevin, I think when you were asking last year about it, this is where I came. Because it has 0, it has 1, so the absence of, the total presence of, like the additive identity, you have the imaginary number, you have pi, and then you have e. The two most important irrationals, the imaginary, the presence, and then the absence. E to the I pi plus 1 is equal to 0. But this exploration, this was like right above section 10.3. It was interesting because it had you playing with Maclaurens in order to build up the Maclaurin series equivalent of e to the ix. Using, I think this is the trigonometric form of a complex number. Cosine theta plus I sine theta. So from the Maclaurens of all these pieces, we could go ahead and show that this is true, and from that, then we can go ahead and try to show that this is true. Muy interesante. All right, if you guys don't have any questions, yeah, feel free to work on the multiple choice. Feel free to work on the homework. I'm going to go ahead and post in Google Classroom the answers to 10-4, 10-5 so that tomorrow you guys can come with educated, informed questions about, like, okay, I know what the answer was supposed to be. I'm just not exactly sure how to get there. So let me go ahead and post that answer key for you guys.
So think of geospheres, right? If R is greater than or equal to P, it's greater yeah, so you had the greater than I don't know. Okay. So when it's sending around the room, it's called a discussion called so you have to know the formula. Oh, okay. Wait, you have to know who assigned this? Yeah. So start this thing. Oh, shoot. So that has to come. The formula. Okay. So you can solve for sine of 1. So you substitute that in 1.
Give me one second.
Wait, can you say that again? So this is a formula. Yeah. Yeah. So it says even the 50 degree, this is what it uses to like. You're not saying 5 degrees.
Oh no, don't do that.
Okay. That was so neat. I'm trying to talk to the side of 1 and plug in 1 to add. Then you get this. You understand? Yeah.